All right, so today is Friday, May 15th, and purpose of the Zoom meeting is I had several students on the Zoom meeting last time asking for help identifying when to do the binomial or when to do the geometric. So that's what we're going to do. However, I'm going to start off with the normal and then lead into that. All right, so first question. And by the way, we're going to use the same scenario for all of these. And so that way you can kind of see how they relate. So a company that manufactures smartphones developed a new battery that has a longer lifespan than that of a traditional battery. For the date of purchase of a smartphone, the distribution of the lifespan of the new battery is approximately normal. That's huge, with a mean of 31 and a standard deviation of 8.32 months. So how do I know to use the normal? They almost always will tell you that it's a normal distribution. So that's almost guaranteed that they'll tell you that it's a normal. So we're going to start with the inverse normal, and here we go. And so when do you use the inverse normal? The question will give you a percent or a probability, and generally it's going to ask you for a value, but it's going to give you a percent or probability. So we're going to start off with percentile ranks. So what is the 80th percentile for months of battery life? All right, so here they've given me a percent, or actually they gave me a percentile rank. And it's kind of important to note that that's a percentile rank, because percentile ranks work from left to right. So basically they're telling me that beginning from the left all the way up to this line, I'm going to have 80%. So this shaded area on this thing is going to be about 0.80, and they've already told me my mean happens to be 31, and the standard deviation is 8.32. I highly recommend you go ahead and draw the little normal curve, label the mean, and show your shading. Just tends to help. All right, just tends to help out a lot. Well, since I know that I'm working with a normal, anytime I know I'm working with a normal, I go ahead and write down Z equals X minus mu over sigma. And it's just a good place to start. And then I start plugging in. All right, so I start plugging in what I know. And what I know is that my mean is 31. And I know my standard deviation is 8.32. But what I don't know in this case is the X, and that's what they're asking for. What is the 80th percentile? So they're actually looking for where that line is drawn. So I'm looking for the probability that Z is less than X minus 31 over 8.32, but I know that that probability equals the 0.80. So I actually have a completed probability statement. Unfortunately, I'm going to have to do something with this. I need to convert this to a z-score. So just taking this, I'm going to convert it to a z-score, which is where I use the second var's inverse norm. So second var's inverse norm, 0.80. And we're working from the left because most of the calculators we have are working from the left. So that's 80%. And we end up getting a z-score of 0.8416. So I'm going to rewrite this. Now I have 0.8416 is less than X minus 31 over 8.32. And I'm going to solve by algebra. So I'm going to multiply times the 8.32. And then I'm going to add 31. So in this case, X is approximately 38. So this value here is about 38, and that tells me that about 80% of my values lie below that X value. Here we're still working with inverse norm. As a matter of fact, this entire page will be inverse norm. It says 10% of the batteries last more than how many months? All right. So 10%. So they have the keywords like more or greater. This indicates that this is an upper tail test. So they're telling me that this area right here is 0.10. All right, we know that this is 31. Now, unfortunately, our calculators work left to right. So in this case, I need to find out this area, which is 0.90. So that's what I'm going to be working with. All right, and once again, because it's a normal, z equals x minus mu over sigma. And I want the probability that z is less than x minus 31 over 8.32. And because our calculators work left to right, I have to use a 90%. Although this is 10%, I have to use a 90%, which was just that 1 minus the 0.10. So this probability is 0.90. And just like in the previous problem, I'm going to convert that into a z-score. So second vars, inverse norm, 0.9, mean of 0, standard deviation of 1, left tail, and I end up getting 1.28. So the probability, so we're now looking at 1.28 is less than or equal to x minus 31 over 8.32, solved by algebra. So times 8.32 plus the 31, and I get about 41.66. So in this case, this x is 41.66. Guess I should scoot that up. Okay, I recognize this one is a slight bit different. Our next problem on inverse norm, 20% of the batteries are less than how many months? Keywords like less indicate lower tail. So in this case, we're at 0.20. Our mean is still 31. And obviously, if we're working from the left, I don't have to do the 1 minusing as I did previously. Once again, z equals x minus mu over sigma. And I'm looking for the probability that z is less than some x that I don't know, minus 31 over 8.32. Second bar is inverse norm for 0.20. And I get a negative 0.8416. So negative 0.8416 is less than x minus 31 over 8.32. Solved by algebra real quickly. And by the way, this problem right here is kind of important because we're going to tie this back later on. Times 8.32 plus the 31. And this is approximately 24. So in this case, our x is approximately 24. Now the reason that's important is because I'm going to use this later. And so 20% of the batteries last less than 24 months. And this was the answer that they asked for. But that means 80% of the batteries last longer. So 80% last longer than 24, and 20% last less. And not important for this part, but we will be referring to this problem when we get to the binomials. Okay, so that was all inverse norm. Now we're just going to go to a straight normal, all right? And you actually have a couple different ways to do these, normal CDF or z-test. Generally, I prefer the z-test, but you can use either one. I'm going to show both of them for a couple times, all right? So anyway, how do I know that this type of problem? Well, it will ask you to calculate the probability for one of something, and that keyword is one. So once again, I've told you the distribution is normal, and they want you to calculate the probability one of something. And I'll also ask for what's the probability of an, and we know by English that that means 1. All right. So what is the probability that a battery lasts more than 1.5 years? Well, first off, they've already given us this information, and we're still working with 31 months. Standard deviation is 8.32. So I need to take that 1.5 years and very simply convert it to months. So 1.5 times 12, giving me 18 months. So they want the probability that it'll last more. This is key word, more than 18 months. So 18 is down here, but because it's more, I'm shading up this way. Technically, I should probably including probability of X is greater than 18. Not required, certainly helpful. Always Z equals X minus mu over sigma. So I want the probability that Z is greater than 18 minus 31 over the 8.32. As you'll notice, we now have every one of the variables filled in, but we don't have the probability. Why? That's what we're calculating. All right, so here we go. And I'm going to do this both with a normal CDF and with a Z-test. So with a normal CDF, second vars, normal CDF, the lower bound, looking at my picture, is 18. My upper bound is infinity. My mean is 31. My standard deviation is 8.32. And it goes directly to the probability. And that's fine. And there's, but what I much prefer is if you use a stats test, Z-test, and here's why. When I do that, my mean is 31, my standard deviation is 8.32, my X value was the 18, but my sample size is 1, and then I just select the arrow, in which that is the direction, which since we shaded up, I needed the greater than. And once again, I get 0.94. But what I like about this method is it gives me my Z-score. So I have the probability that Z is greater than negative 1.5625, and that happens to equal the 0.9409. And that's my final answer. All right, so about 94% of the batteries will last at least 18 months. Recording. So what is the probability that a battery lasts less than 4 years? Once again, we're working in months, so 4 times 12 is 48. We know that our mean is at 31. So now we're talking about 48. So we're somewhere up here, somewhere above it, and we want less than 48. So technically, probability that X is less than 48, Z equals X minus mu over sigma. And I want the probability that Z is less than 48 minus 31 over 8.32. And once again, you can do this by normal CDF, and I'll do that real quickly. So second vars, normal CDF. In this case, my lower bound is negative infinity, because I can tell that by the shading. My upper bound is 48. My mean is 31. My standard deviation is 8.32. And I get about 98% as my answer. Now, the only thing I really don't care about the normal CDF is I really should be calculating my Z-score by hand. But other than that, it's a great tool. So if I go stats test, Z-test, and I already have the mean of 31, standard deviation 8.32. We're changing our X to 48. Once again, and I should have said this earlier, they say a battery. So that means 1. So my sample size is 1. And because I shaded down, I need to be using a less than, which is that one. And we end up getting the probability that Z is less than 2.043, and that equals 0.9795. And that's my answer. All right. Moving on to the next one. What's the probability that a battery lasts between 2 and 3 years? Okay, keyword there is between. I'm going to turn these into months. 2 times 12 is 24. So we have 24 and 36 months. Our mean is still 31. So we're somewhere below here at 24, somewhere above here at 36. So I'm looking for this shaded region. All right. So this means I have, if I have 2 boundaries, which means I need to set up two formulas. So in this case, Z equals X minus mu over sigma. And we're looking for the probability that 24 is less than X is less than 36. So here's what I do. I always start with the higher value because I subtract the smaller value from the higher. So the probability that Z is less than 36 minus 31 over 8.32 minus the probability that Z is less than 24 minus 31 over 8.32. Now, this is a really nice time to actually use the normal CDF, and I am going to do this both ways. So second vars, normal CDF, lower bound, looking at my chart, is 24. Upper bound is 36. Mean is 31. Standard deviation 8.32. And right there, we are done. Okay, so it did everything all in one moment. That equals 0.526 approximately. Now, once again, it didn't give me my z-scores, and I'd be best if I went back and calculated those by hand. So if I had chosen to use the stats test, this is the differential. Stats test, z-test. Once again, we want to start with our upper value. Our upper value was 36. We're still going to be less than because we're going to the left. And we end up getting a z-score of about 0.6. So the probability that z is less than 0.6009, and we happen to know that that probability is 0.7261, so I'm going to go ahead and write that down. 0.7261 minus, then I need to do go back and do the other side. So stats test, z-test, change my x to 24. This is still going to be a less than. And now I have minus the probability that z is less than negative 8413. And that probability is about 20%. All right, so 0.7261 minus 0.20 is 0.526, which is what we got over here. So there's 2 methods to approach that. All right, so we are still working with the same scenario, and the distribution of means. How do I know when to use it? Well, the problem tells you the distribution is normal or n is greater than 30. So if n is greater than 30 or the distribution is normal, they tell you that. And this is really important that and, they ask you to find the probability for the sample mean or sample average or X bar. Those are the key things you're looking for. All right, sample mean, sample average, or X bar. Then and the distribution is normal or sample size is 30 or larger. Then you can go ahead and use uh, distribution of sample means. So what's the probability that a group of 5 batteries will have a mean life expectancy more than 27? Well, guess what? They've already told us up in a scenario that we're working with a normal population. So we know we're working with a normal. So I don't worry about the sample size being less than 30. And they're asking for the mean life. So as soon as they say that, I start writing down, well, what does that look like? X bar, because we're looking for the mean, mu, and then the standard deviation, sigma, divided by the square root of n. So basically, we have an average. Well, averages mean we added a bunch up and divided by n. So that means I need to do the same as the standard deviation. All right? Once again, our mean is at 31. And we'd like to know more than 27. 27 is below. But they said more, so I need to shade up. And that's what I'm looking for. So the probability that z is greater than, because we're shading up, 27 minus 31 over 8.32 divided by the square root of 7. Oops, square root of 7. And this is probably best done in a z-test. So stats test, z-test, 31, 8.32, 27. But now my sample size is 7. All right? So we have an up arrow because we shaded up. We calculate, and we end up getting the probability that z is greater than negative 1.27. That equals 0.8983, and that's our answer. Now, I'm going to also show you how to do this doing the normal CDF. All right? With the normal CDF, please keep in mind that's my standard deviation. So, second vars, normal CDF, lower bound was 27 based on this, upper bound is infinity. My mean is still 31. My standard deviation is 8.32 divided by the square root of 7. And that's, I just do 7 to the half power, but you can use the square root sign if you prefer. And obviously we get 0.8983, same thing. All right, so 2 different ways to approach that problem. All right, pause for just a moment. All right, so it was pointed out to me that I made one of my typical errors, careless one. My sample size was not 7, it was 5. I'm going to use 7 later, so I'm going to go ahead and recalculate this. So stats test, z test, and I'm just going to change my sample size to 5. And of course, my z-score and my, along with my probability are going to change. So this should have been the probability that z shaded up is greater than negative 1.075 equals 0.8588. By the way, I appreciate the correction, and sorry about making you guys watching the video giving you all heartburn. Apologize for that. So the probability that z is greater than negative 1.075, and once again, that should have been a square root of 5, not a square root of 6. All right, so moving on. What's the probability that a group of 7 batteries, see there's 7, have a mean life that is less than 27 months? So we're still working with 27 months, but now we're talking about less than, so I'm looking for that shaded area. So, and really this is the probability, not that you have to show this, but the probability that X bar is less than 27. Well, but once again, here's the key word, mean life, all right? And even though this is not greater than 30, because the underlying distribution is normal, I can still use a normal. So the probability that, the equation z equals x bar minus mu sigma over the square root of n, that's just good practice. You should do that every time on a test so that people know that you know. And in case you do a plug-in error like I did, they're likely to sit there and go, hey, that was a careless error. And actually might even give me full credit even though I did that, as long as I have this here. Okay, this here, along with the chart, they're going to sit there and go, careless error. He's probably, they're at least going to give me partial, if not full, for making that type of mistake. So probability that z is less than 27 minus 31 over 8.32 divided by, this time it is the square root of 7. And the reason I chose less than, because I was shading this direction, I'm shading to the left. So stats test, z-test, changing my sample size to 7, changing my direction to less than. And now I have the probability that z is less than negative 1.27. And that equals 0.1017. All right? Okay, next problem. What is the probability that a group, and y'all's doesn't have this, or it may not show up on y'all's because I don't think I made that correction, of 7 batteries, so I wanted 7 here, 7 batteries, have an average life between 28 and 33 months. Once again, our mean is 31. Here we're sitting at 28. And here we are at 33. So I'm looking for the in-between, which means I need to be subtracting. So we're doing the probability that 28 is less than x bar, make sure it's an x bar because we're working with the mean, is less than 33. So z equals x bar minus mu, sigma divided by the square root of n. So in this case, the probability, I always start with the larger value or the upper value, probability that z is less than 33 minus 31 over 8.32 divided by the square root of 7 minus the probability that z is less than 28 minus 31 over 8.32 divided by the square root of 7. And now I'm going to go ahead and run the z-test twice. I'm going to begin with this one here, the larger one. So stats test, z-test. I'm going to change my x bar to 33 because that was the upper part of the shading. My sample size is still 7. And I get the probability that z is less than 0.636. Put a minus sign there. And that probability is about 0.7376. Put a minus sign there. And then I'm going to go run the other side of this, which is going to be stat test, z-test, one more time. Now I've changed my lower bound to 28. Sample size is the same. And I end up with minus the probability that z is less than negative 0.954. And this is about 0.1700. I subtract those two values. 0.7376 minus 0.1700. And I end up getting a value of about 0.5676. Now this also could have been done with a normal CDF, so I'm going to do that really quickly. I'm not going to write anything down, but I'm going to show you how to do it real quickly if that's the way you prefer. So second vars, normal CDF. My lower bound in this case is 28. My upper bound is 33. My mean is 31. 8.32 is a standard deviation, but it's 8.32 divided by the square root of 7. So divided by the square root of 7. And we still get to 0.5676. So that's two separate ways in which that problem could be approached if you prefer the z-test or the norm CDF. Either way is possible. Okay, so we've been working with the normal, but that really wasn't what people were most concerned about. What they were most concerned about was the binomial PDF and CDFs and the geometric PDFs and CDFs. So we're going to still keep with the same scenario, but notice I added this highlighted part. It says 20% of the batteries will last less than 24 months and 80% will last more than 24 months. We actually calculated that earlier when we did the inverse norm. So I'm going to go ahead and say this right here was my mean at 31. This is 24, and this represents 0.20. This is 0.80. All right, so at 24 months, 20% lasts less and 80% lasts more, because I need to be paying attention to what they're asking for in the question. All right, so how do I know when to use a binomial? All right, I use the binomial when the problem has a given probability and a fixed number of trials. So in other words, the probability of success is this, or the probability of failure is this. And one of the key phrases to look for is out of. So please note, I'm going to be working with 24 months, and we know from previous calculations that 24 months is at 20%, or if it's more than 80, it's at 80%. So we've already done that calculation. So for 24 months, we have a fixed probability. We don't have a fixed, the other probabilities change, but at 24 months, we know it's fixed. So again, I'm looking for the phrase out of. So the binomial PDF, how do I know when to use it versus when to use a CDF? Well, I use a PDF when I know it's a binomial and they're looking for a specific number of successes, not a range of successes, but a specific individual value. We want 1 success, we want 3 successes, we want 10 successes, we want 0 successes, whatever that is. So I have to pay attention to that, whether that's one value or a range of values. So in this case, it says out of, and that's that phrase, oh my goodness, out of 10. That tells me I have 10 trials. You don't have to write this down, but 10 trials. Probability, that's 7. Oh, 7 is going to be my number of successes, but I need to know what the p-value is. And it says last more. Oh, we want to last more than 24 months. More is up here. So this is the more side. So in this case, our p-value is 0.80. All right, so our p-value, our probability, I shouldn't say our p-value, our probability is 0.80. So we should probably write down the generalized formula, which is n choose x, probability to the x, 1 minus p, and then n minus x. Okay, is that required? No. If you make a mistake later, that can get you points. So that's the only reason to do that is if you make a mistake. The next thing I need to show my plug-in, and I have to show this. 10 choose 7, my probability is 0.8, and we want 7 successes. 1 minus 0.8, and this is 10 minus 7, which is 3. I've now shown all the work that I need to show, and I can go straight to the calculator. So second quit, second vars, binomial, PDF, because it was a specific number of successes. We only circled that we needed exactly 7. I didn't circle multiple values. So I have 10 trials. My probability was 0.8 because it was the more than that we shaded. and the X value happens to be 7. And so that's about 0.201. So our answer is 0.2013. So basically what we just said is we would expect about 20% of the, if we had a group of 10 and we wanted to know what's the probability that exactly 7 will last more than 24 months, our answers would be 7. I mean 7, and that happens 20.3% of the time. All right, trying to find that pause recording. All right, so now we're moving to the binomial CDFs, and I know where the CDFs tends to be where a lot of confusion occurs. So when to use? First off, the problem has to be at binomial, which means we need to know a probability, and it has to be a fixed probability. But this time, instead of asking for a singular value, they're asking for a range of values. Keywords are like less than, fewer, no more than, etc. And we'll get to another set in just a moment, the 1 minus. Right now, just working with those. So once again, the key phrase to look for is out of. So we have out of 10 batteries, what's the probability that more than 2 will last more than 24 months? So so we have more than 24 months. So that means our probability is the 0.8 because that's the more than. And we said that no more than 2, all right, will last more than 24 months. So basically, no more than 2 means I'm looking for those 3 values, 0, 1, and 2, all right? Because that's no more than 2, that's no more than 2, that's no more than 2. It really helps to make a little number line like that. So once again, now I'm looking at multiple values, so I have a range. Because I have a range of values, I'm going to use the binomial CDF. Still probably should write down the binomial formula, n choose x, p to the x, 1 minus p to the n minus x, so that's the formula. But I have a range of values, and this is where I'm going to do the bookends. Please remember that I need to do the lowest and the highest. If I want to include all 3, that's fine, but I at least need to include the lowest and the highest. So I'm going to do that. So the number of trials in this case is 10, because they tell me 10 batteries. My lowest in the range is 0. Actually, I'm going to scoot over here, otherwise I won't have enough room. 10, choose 0. 0.8 is my probability, so 0.8 to the 0. Then 1 minus 0.8 to the 10th, plus dot, 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 plus 10, choose the highest value, or excuse me, which is a 2. That's the highest value that was acceptable. 0.8 is the probability. 1 minus 0.8, 10 minus 2 is 8. That would be the work shown, in which case I can go to the calculator and do a binomial CDF. So second vars, binomial CDF, 10 trials, P is 0.8, our probability is 0.8, and our X value, because we're working from left to right, and remember the calculator always works left and right, we're choosing the highest value that's below the line. Well, the highest value below the line is 2. So we end up getting a pretty small probability, 0.00008. And you could probably cut that out. You can probably just call that 0 if you wanted to, but that was the actual value that I got. So you can call that 0 because you have 4 zeros there. As soon as you have 4 zeros, you can say approximately 0. Out of 10 batteries, what's the probability that fewer than 2 will last less pause this for just a second. All right, resuming, I basically did not quite write the problem I wanted, but this will still work. So out of 10 batteries, so we have that phrase that's out of 10 batteries, what's the probability that fewer than 2, so less than 2, so here's our less than 2, 0, 1, will last less than 24 months. Less than, this is my less than 24 months, value is 0.2. So my less than 24 months is the 0.2. So once again, n choose x, p to the x, 1 minus p to the n minus x. We have, in this case, 2. So 10, choose 0. We said less than value is 0.2. So 0.2 that should have been to the 0, excuse me. 1 minus 0.2, 10 minus 0 is 10, plus 10 choose 1, 0.2 to the first, 1 minus 0.2, 10 minus 1 is 9. All right, so that would be our work shown. Second vars, binomial CDF. Trials is 10. Our p-value has now changed to 0.2 because we have the less than 24 months, which is 20%. And our x value, we always take the highest value below the line. So this is what we want, is the highest value below that is 1. And there's about a 30.3758, or about a 38% chance that fewer than 2 will last less than 24 months, right? All right. Feel like I need to ask some questions on that. All right, so resuming recording. The 1 minus binomial CDF, when should we use that? Use when we have a binomial, and it's asking for a range of values, and the keywords that let us know we're using a 1 minus are at least, or more than, or greater than. All right, so out of 10 batteries, there's that phrase again, out of 10 batteries, what's the probability that at least 1 will last less than 24 months? All right, at least 1 will last less than 24 months. Well, at least 1 could be 1, that's at least 1, that 2 is at least 1, 3. So all the way up here is at least 1. Calculator works left to right. So we're essentially going to do a 1 minus the probability of 0. But notice they said last less, so that means we're going to use the 20% value that we set up here, because the 20% was last less. So this is a last less situation, and we're going to go 10 choose, n, off the side, n choose x, p to the x, 1 minus p to the n minus x. All right, so in this case, our work's going to look like this: 1 minus 10 choose 0, because that's the highest value, that working from left to right. 10 choose 0, probability of 0.2 because it was the less than to the 0. 1 minus 0.2, 10 minus 0 is 10. I'm going to put those in brackets just out of good math notation. So that's my work shown. So this is a binomial CDF. So 1 minus, second vars, binomial CDF, 10 trials, probability is 0.2. X value, in this case, the highest one below the line is 0. And when we do that, we end up getting a value of about 0.8926. So about 89% of the batteries, the probability that at least 1 will last less is this. All right, the probability of at least 1 is this. All right, so we're moving to the last one of the binomials, and it says out of 10 batteries, so out of, there's that phrase again, what's the probability that more than 8, so more than 8 means not including 8, that's going to be 9 and 10, will last more than 24 months. Well, we said the more than 24 months was the 80% value. So this means right here, I'm working with the 80% value because it was the more than. Once again, n choose x, p to the x, 1 minus p to the n minus x. And these are the ones that fall into the 1 minus situation. So in this case, 1 minus, I need to make a lot of room, 1 minus, I have an entire range that I need to subtract. So 1 minus bracket, 10 choose 0, 0.8 because it was the more than, 0.8, and then 8 to the 0 from here, and then 1 minus the 0.8, 1 minus 0.8, 10 minus 0 is 10, plus dot, 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 plus. And the highest value not selected was an 8. So in this case, 10 choose 8, 0.8 to the 8, 1 minus 0.8, 10 minus 8 is 2, close the brackets, work shown. So once again, 1 minus second vars, binomial CDF, 10 is the trials. This time we have an 80% because we have the last more. And my X value is 8. All right. So that takes care of that one. All right, so working with the geometric. Once again, we're still working with the same situation. We have 20% will last less than 24 months, 80% will last more. We did that previously. This is the 31 months that we expect them to last, but we said if this is 24 months, this is 0.20 for less, and then we have 0.80 for more than. All right, so geometric distribution. The problem has a fixed probability. Well, here we do, we're fixed at either 20% or 80%, depending on whether they said less than or more than, all right? But we are looking for the first that occurs, all right? So the phrase that indicates first or something that indicates that, that's what we want to use. That lets us know we're doing that. Geometric, we use when we have a specific singular value, just like when you use the binomial PDF. So what's the probability of the first battery that works less than 24 months is the third battery tested? So first off, we're working with a less than. We know that because it says works less than 24 months. And they want the third battery tested, and there's that keyword first. Now, there's a formula you can use. I don't like it. I think it's more complex. So I sit there and go, to me, this is where accounting principle makes more sense. I go, you know what? 1, 2, 3. This is a success. This means this is a fail. This is a fail. So my probability of success is 0.20. So these are going to be 1 minus 0.20, so 0.8 and 0.8. And if this is all the work you showed, they're going to be thrilled. All right, so that's definitely full credit work right there. And 0.8 times 0.8 times 0.2 is 0.128. So fail, fail, success. There you go. If you wanted to do 1 minus 0.2 times 1 minus 0.2 times 0.2, that would take care of it. So that's the idea behind the geometric PDF. All right, the geometric CDF, when you use when the problem is still the same situation and we're still looking for the first, but now we're talking about out of a group. When does the first one occur out of this group? So keywords are like among, before, no more, etc. Right? So basically it's like, oh, I identified that it was a geometric because it said first, and they want to know the probability that it occurs among or before or no more than. All right? So what's the probability that the first battery that works less than 24 months is among the first 3 batteries tested? So we have a less, so this tells me my basic probability is 0.2. And it says, what's the probability the first battery that works is less than 24 months is among the first 3? So technically it could be the first one, the second one, or the third one, just so long as it's among those groups. So I need to sum up all those probabilities. I do that by showing all the individual PDFs, okay? And if I only have 3, I'm going to show them all, but I'll show you what to do if you have a longer list in just a moment. So the probability that it's the first one means I had no failures, so the probability of the first one is success on the first one, which is 0.2. All right, so that takes care of this one. Plus, the probability occurred on the second one. Well, that means I have 2 blanks, which is a fail and a success. So this is going to be 0.8 times 0.2. And then the probability that occurs on a third one is what I just previously did, which is going to be a fail, fail, followed by a success. So my success probability is 0.2. These are 0.8. And I sum all of those up. Well, the way I can do that very quickly is I can go to the geometric CDF, second vars, geometric CDF. My probability is 0.2, X is 3. And I have 0.4888. There's about a 49% chance that my first success would be among my first, or the first battery that works less than 24 months occurs among the first 3 batteries. I don't know if you can see these, but these are dots because this technically goes on to infinity. It is possible that we would never have the first one. It's kind of like, hey, when am I going to have my first kiss? And it's like, hey, it never happened. All right, that could happen. All right. So next thing, what if they said, hey, what a probability is among the top 10? Well, there's no way we're going to want to do 10 of these. In which case, I'm going to show the first 2, then the last one. All right. So, and then just bookend in between. All right. So you can do the plus dot, 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 but I always like to include 2 here and then 1 up there. So on this one, I like to show 3. So I'm going to pause this. All right. So the 1 minus geometric CDF. Keywords are very similar to the ones that you use for the binomial. So you need to identify whether or not it's a geometric or binomial. So a geometric is going to have the word first. What's the probability of the first success? Whereas the binomial is going to say out of 10 or something like that, or something along those lines. Here, we're looking for the first. So what's the probability that at least 5 batteries must be tested in order to find the first battery that works less than 24 months? Well, basically what they're telling me is at least 5. So 5 all the way up to infinity. I mean, I'm sorry, I can't go to infinity, but it's going 5 to infinity. So consequently, they have the phrase at least, so I'm going to use 1 minus. So here's what I do. 1 minus, bracket, the probability that it occurs on the, and basically I'm going to subtract out everything I don't want. Well, I want 5, I want 6, I want all the way up to infinity. So I don't want 1, 2, 3, and 4. So those are what I'm going to subtract out. But I'm not going to show all of that. I'm going to show the first 2 and then the last one. So the probability of this one is, hey, the probability of the success occurred on the first one, 0.2. Plus, probability of the success occurred on the second one means I had a fail, then a success, So this is 0.8 times 0.2, dot, 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 plus signs. And then the fourth one means 1, 2, 3, 4, fail, 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 success. So this is 0.8, 0.8, 0.8, 0.2. All right, and that would be my work shown. On the calculator, 1 minus second vars, geometric CDF, probability is 0.2, x value is 4, and I get 0.4096. So there's about a 41% chance that I'd have to test at least 5 batteries in order to find one that worked less than 24 months. In other words, about 60% chance that among the first 4 batteries I'd find one, and about a 41% chance that it's above that. Okay. All right, last question. So what's the probability that more than 2 batteries must be tested in order to find the first battery that works more than 24 months? We had been working with less, but now we're working with more. So this was 0.80. So we changed that. And 0, 1, 2, 3, dot, 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 all the way to infinity. And what's the probability that more than 2 batteries must be tested in order to find the first battery that works more. So more than 2. 2 is not more than 3, but 3 is. All right. Oh, and by the way, we never have 0. For geometric, that's the difference between a geometric and a binomial. The first success can't happen on 0. The first success could be on the first, second, or third, or anyone after that. With a geometric, you can't have 0 successes. With a binomial, you can have 0 successes. You're on a multiple choice test or 5 questions. What's the probability you get all of them wrong? You can get 0 successes in a binomial. So what's the probability more than 2 batteries must be tested? Because this is a more than, because we circle to the right-hand side, we're going to do a 1 minus. We're going to do the bracket. And the bracket for the first one is we have a success on the first one and no failure. We said our success was 0.8. For the second one, fail and success. So this is going to be 0.8 times 0.2. Close brackets. I should have shown the 1 minus. 1 minus second vars. Geometric CDF, 0.8, x value is 2, and you end up getting 0.04. Okay, that should close up on geometrics.